Hello, my name is Praveen. This is my video submission as part of the probability homework plan. So the first problem goes like this. In the first problem, we are asked to prove or disprove this expression. So what I'm going to do is I'm going to keep this equality as they have given in the question throughout the problem. In the end, if this equality turns out to be true, the LHS and RHS turns out to be true according to this equality, uh, then the question is proved, otherwise it is disproved. So I'm putting a question mark besides all the steps, since we don't know if this equality is true. So going through the problem, the LHS is nothing but a conditional probability expression which can be expanded this way. It's of the general form P of A given B is P of A intersection P of B by P of B. The LHS remains the same. The addition of these two terms leads to this expression divided by P of C. Since I have P of C on both the sides, I cancel them out. So now the LHS is nothing but P of A union B intersection P of C, which is nothing but P of A union B intersection with P of C is this area. This area can also be written as P of A intersection C, which is this area, plus P of B intersection C, which is this area, and we need to subtract the intersection of all the three probabilities, since it is added twice when we added these two terms together. So we get the expression of LHS as this. So going to the RHS, the RHS is P of C minus P of A union B union C. Since P of A union B union C is bound to be greater, for the sake of simplicity, I take out the minus outside the bracket, so we end up with this expression. So now P of A union B union C can be expanded as P of A union B, which is this area, minus P of A intersection C, which is this area, minus P of B intersection C, plus I add this area. Since we subtracted this area, since this area was subtracted twice, I add this expression. So now I use LHS and RHS expression in this equality. So P of these two expressions which are same gets cancelled out, these two cancel out, these two cancel out. So I end up with the expression 0 greater than or equal to minus P of A union B. So now I multiply the minus on both the sides, which reverses the operator in the middle. So P of A union B greater than or equal to 0. So I still don't know if this is true. So I've been putting question mark all along. But now since I've arrived at this expression, and I know from the axioms of probability that the probability of any expression is always 0. It can never be negative. It can be 0 or it can only be a positive value, since this expression also proves that. Therefore the question is proved.